Hey guys, today we're moving on to area now, and we're going to start off with looking at triangles and quadrilaterals. So that will be calculating the area of shapes with 3 and 4 sides. Before we get into that though, I have a quick revision question here for you. I'd love for you to pause the video now and have a go at this question yourself. When you unpause, I will show you how to do it. Okay, so we're looking to calculate the perimeter of a sector here. So the first thing we need to do is we need to get the circumference of the whole circle, which is going to be pi times 2r . Okay, so I'm just going to put that into my calculator. And that's the answer I get. Now, it looks like we have one quadrant removed from this circle, which is 1/4 of the circle. So what we have remaining is 3/4 of the circle. So if I wanted to find 3/4 of the circumference, all we have to do is times by 3/4. And that will give us 3/4 of the circumference. And the answer to that is 37.227, and then a lot more decimals in the calculator. So when we round that off, that will be 37.23 centimeters. So that gives us the distance of this line from here all the way around to here. So now to get the perimeter, we have to take that distance and we have to add on this distance and this distance. Now both of these are the same because this distance here, the side of our sector, is the radius of the circle. So if this one is 7.9, then this one, also being the radius of the circle, is also 7.9. And then you can just add those up and you get 53.03 centimeters. Right, moving on now. Before we look at calculating area, let's make sure that we have a clear picture in our head of what area is. So I have a rectangle here. Let's imagine now that I have a section here that is 1 centimeter. And then this way I have another section that's also 1 centimeter. If I made myself a little box here out of 1 centimeter lines, what this is called is 1 square centimeter, or 1 centimeter square. Because it is a square with the sides of 1 centimeter. And essentially what we're calculating when we calculate the area of this rectangle is we're calculating how many of these boxes can we fit. How many of these boxes can we fit in this whole space? That's what we're talking about when we talk about area. Now let's look at exactly how we calculate it. Here we have a number of formulas for slightly different shapes, and I don't necessarily expect you to remember all of these exactly, especially these two. You don't necessarily need to commit those to memory, although if you can, it would be helpful. But the two that you absolutely do need to remember are these two: the area of a rectangle and the area of a triangle. Because from these two areas, we can actually calculate all of the rest. If we know the angle of a rectangle, we can calculate the area of a parallelogram or a rhombus, because what we should be able to realize is that if we cut our parallelogram here and take this part that we cut off and put it in here, what we actually have is a rectangle. So we calculate the area of a parallelogram or a rhombus in the exact same way we calculate the area of a rectangle. And again, what we can notice here with the rhombus is that it's just made up of 4 triangles. So if we remember how to calculate the area of a triangle, we can calculate the area of a rhombus as well by calculating the area of the triangles that make it up. And again, here with the trapezium, if we really got stuck, we could split it up into a rectangle and 2 triangles, and we'd still be able to calculate the area if we didn't remember this formula, but we remembered these two. So that's what I want you guys to make sure you do, is you commit these 2 area formulas to memory. For a rectangle, it's the length times the base, or the base times the height, or the width times the height. You'll see these sides called different things depending on where you look, but the important thing is that it's one of the sides times by the other side touching it. Okay? We don't times this side with this side. We times together 2 sides that are touching each other. And then a triangle is straightforward. It's the same, it's the base times the height, but because a triangle is only half of the rectangle, if we imagine a little rectangle here, the triangle inside only takes up half the space, so we have to stick the times by a half out the front. Now, let's just do some examples. Let's calculate some examples. In the first one, A, we have a simple rectangle. A equals base times height, which is 7 times 3. 21 meters squared. Now this is important. When we're dealing with area, our units always have a squared. Because really what this line should say here is not just 7 times 3. It should say 7 meters times 3 meters. So we've times the 7 and the 3 together to get the 21. And then we've times the meter and the meter together to get meters squared. That's how you can think of it to help you remember if you need to. Okay, now the second one is fairly straightforward again. It's a triangle, so our area formula has the half out the front. A half times the base, which is 11, times the height, which is 5. Okay, we put that in our calculator, and the answer is 27.5 kilometers squared. Oh, sorry, that should be 2, not 3. Now, again, we have a parallelogram which has the exact same area formula as a rectangle. And, whoops. The answer here is just 4.5 centimeters. Again, don't forget the squared. Now, looking at some more complex shapes. The rhombus. Now, the area of a rhombus formula is half xy. But remember, if we couldn't remember this, there are 4 triangles here. Or even 2 triangles. One triangle here and one triangle there. We could calculate the area of this rhombus by calculating the area of both those triangles, because remember, we're going to know the area of a triangle formula. But in this case, we have the area of a rhombus formula, so we're going to just use that. A half times 10 times 9 is going to equal 45. And again, don't forget the squared. Now let's look at the formula for the area of a trapezium. And let's just fill in all the numbers. So that's going to be a half times 3 times 10. Remember our order of operations, we do what's in the brackets first. And the answer to that is I put that into my calculator wrong. That's should be 15. Okay, for this lesson, guys, you're going to have a choice between going to this page in the textbook, 295, and doing question 5 and question 6. If you think you're pretty comfortable with doing these area calculations, I'm going to suggest that that's where you go to the textbook. If you're still a little bit confused and you want a bit more help, then I am going to encourage you to choose the Education Perfect lesson. The link will be on our line just below this video. Thanks, guys.